Welcome to video lecture number 1, Chemical and Physical Changes. This unit is all about chemical changes or chemical reactions. But chemical changes often get mixed up with physical changes of matter. To really understand the difference, we need to be on the same page with certain vocabulary terms. Go ahead and pause the video and write down the essential question in your notes. So let's talk about a few words. Here's sort of the textbook definition of a chemical change. A chemical change is the formation of a new substance during a chemical reaction. The new substance is called the product of the reaction. It has different chemical and physical properties than the substances that reacted. Those are called the reactants. We're going to use the word substance and the word properties a lot during this unit, so you may want to write their definitions down. When I say substance, I'm just talking about some matter. It could be an element from the periodic table, but usually we deal with compounds, or elements that have already bonded together to make molecules. A chemical reaction takes place when atoms of substances rearrange themselves to form new substances. Take a look at the chemical reaction represented by the images to the right. My son always leaves my tools out in the yard. It drives me nuts because they rust. Iron rusting is an example of a chemical change because a new substance that has new properties is produced. This chemical reaction causes iron, a shiny hard metal, to react with oxygen gas, an odorless, colorless substance in the atmosphere. These two substances are called the reactants. The product, the new substance that is formed, is iron oxide, or rust. It has completely different properties than the reactants. It's an orange, brittle solid, kind of flaky, not at all similar to the iron or oxygen that it's made of. Notice in the chemical equation down here, a written way of representing a chemical change, that the two elements, iron and oxygen, bond together to form a compound. Atoms of substances are rearranged in a reaction to form new substances. In other words, atoms break bonds that they have and create new bonds with other atoms during a chemical reaction. Now that we've defined a chemical change as the rearranging of atoms to form new substances that have new properties, let's talk about properties. Different types of matter, including elements and compounds, have different properties or ways to describe the matter. We can use these properties to identify specific types of matter. For example, when you hear the word lemon, what thoughts come to your mind? You probably think of the color yellow or a sour taste. These are all properties that describe lemons. Properties of matter are either physical or chemical. A physical property is one that you can observe without changing the matter itself. Some examples of physical property of matter include color, density, and melting and boiling points. Its state of matter, solid, liquid, or gas. Whether it's magnetic or it conducts electricity well. How it tastes. These are all examples of things that you can observe without changing the substance. We could weigh these bars of gold or measure their volume or calculate their density to check and see if they're really made out of gold without changing the gold into something else. Matter can undergo two types of changes: physical changes and chemical changes. Physical changes involve changes to a substance's physical properties only. Some common physical changes that are often confused with chemical changes are freezing, melting, evaporating, and dissolving. If you dissolve something in water, you do change its properties. For example, if you dissolve salt in water, a white solid becomes a translucent liquid. It's a mixture of salt and water. But the chemical properties of the salt and water remain the same. In fact, most of the physical properties of that mixture are the same. If you tasted salt water, it would taste like salt and water because it is just a mixture of those two substances. The two substances in a mixture, in our example salt and water, are not rearranged to form a new substance that has new chemical and physical properties. The same goes for boiling or melting something. If you take an ice cube and melt it, you change one of its physical properties, its state of matter. It goes from a solid to a liquid, but you are not producing a new substance. The water is still water when it melts. It still has the same chemical properties, and it has many of the same physical properties. So don't confuse mixing or dissolving, melting or boiling as a chemical change. In the back of your mind, you should be thinking, is a new substance produced by this change? Have the chemical properties of the substance been changed? Another example of a physical change is making a paper airplane. If you make a paper airplane out of a sheet of paper, the paper doesn't undergo a chemical reaction. Its chemical properties don't change. With the paper airplane, you can undo that physical change fairly easily. To turn the paper airplane back into a sheet, you just unfold it. It's the same with the ice. To turn an ice cube back into liquid water, simply melt the ice cube. Again, when trying to decide whether something is a physical change or a chemical change, ask yourself, is a new substance being produced, or am I just changing substances in a physical way? A chemical property is very different than a physical property. You can't observe it just with your five senses. You can observe it only when the matter changes as the result of a chemical reaction. An example of a chemical property is flammability, or how easily a substance catches fire. That's something you can't figure out unless you try to set it on fire. Another chemical property is how a substance reacts when exposed to different kinds of chemicals. For example, if you add lemon juice to a glass of milk, lemon juice is acidic. It causes the milk to curdle, or it forms large chunks. Curdling results from a chemical reaction between lemon juice, an acid, and milk that changes each of those two substances into a new chunky solid. This happens all the time at my home when I burp my 1-year-old. The 1-year-old drinks the bottle of milk. It interacts with the hydrochloric acid in her stomach, and as I pat her to sleep, she throws up white, chunky solids on my shoulder. Chemical properties can only be observed during chemical reactions. Chemical changes involve changes to the physical and chemical properties of a substance. During a chemical change, atoms from substances rearrange to form new substances with new properties. Burning a piece of notebook paper changes the paper's physical and chemical properties. Initially, notebook paper is white. You can crumple it and rip it, but it maintains its original color and composition. It's still paper. When the paper burns, however, it changes to black, flaky ashes. The ashes are a new type of substance that does not resemble the notebook paper. And it also becomes carbon dioxide gas, another new substance. Unlike physical changes, chemical changes usually cannot be reversed. They're difficult to reverse in most cases, and sometimes they can't be reversed at all. You can't unburn the ashes to get back the original paper. Now, chemical changes can be reversed at times. We could separate water into oxygen and hydrogen gas, and then in a separate chemical reaction, we could rearrange them to form water again. In most cases, though, chemical reactions are irreversible, or they're very difficult to reverse. Whenever trying to determine whether or not a change is physical or chemical, just keep in the back of your mind, is a new substance that has new properties being produced by this change. Thanks for watching.